Welcome everyone on our weekly learning session. I hope everyone had a great week. My name is Daniel Bigos, and today, together with Hector and Abhishek, we are going to talk about the Pallet assets. Let's talk about the purpose of that session and also about the agenda. So the session is about teaching about the assets overall on Polkadot and Substrate, and also to go into details of the assets palette. And once talking about the agenda, at first I'm going to provide some overview about assets. Then we will talk about the pallet assets. Then I will show some dependencies with other pallets and tools. Then I will talk and present how it is used in Substrate and Polkadot. Then Abhishek is going to provide some demo about the pallet assets. And then we will have Hector, who will provide code walkthrough. After the walkthrough, we will have Q&A session. Before talking about pallet assets, let's talk about assets in general. We have two types of assets. At first, we have fungible assets. And what are fungible assets? So, fungible assets are those assets in which units are interchangeable. What does it mean? So, to better visualize what fungible assets are, I will use as an example fiat money. So, think about US dollars. So, imagine we have $1. So that $1 is equal to any other $1. So that's our fungible assets that they can be exchanged and they have the same value. On the other hand, we have non-fungible assets, and with non-fungible assets, each asset has its own unique value. For example, we can think about assets representing some real values, like we can have an asset representing my apartment, and we can have an asset representing Hector's apartment. And our apartments are different, so our assets representing our apartments are different, are not exchangeable. Today, we are going to talk about fungible assets, and that fungible assets are enabled in Polkadot ecosystem with the assets palette. Before talking about pallet asset itself, let's talk about some terminology. So with the asset stuff, we have some processes. The first process that is about asset management, playing with assets on Substrate and Polkadot is asset issuance. So asset issuance is a process of asset creation and minting some initial supply and assigning that supply to the asset owner, asset creator. Also, we have asset transferring. What is asset transferring? It's the process of sending some assets from one account to another. We also have a process, a term called asset destruction. So the process is about removing, destroying assets from an account or even from a chain. Having described some processes, some terminology, let's talk slightly about roles that are defined within the pallet asset. And the first role that comes to mind is asset owner. An asset owner is at the very beginning asset creator, and with the role of asset owner, account, person, entity can manage the asset, can, for example, set asset metadata that I will describe later, can set roles that we discussed in that moment. Besides asset owner, we have also asset issuer, and issuer role is responsible for minting, creating new assets of a specific class. Besides issuer, we have also a role called freezer. And what even freezing asset means? So it is like locking, preventing assets from transferring using in any other way. And asset freezer can freeze assets on a specified account or even can freeze the whole asset class on the chain. Besides asset freezer, we also have an admin. So it's kind of super user who can do, for example, force transfers or unfreeze accounts. So actions that are taken without asking anyone for permission for doing that. So we have covered some roles corresponding to assets. So what's the entry point to the assets? So to start with assets on any chain that use Pallet asset, we need to create an asset. And for asset creation, the only thing that we need is to provide unique identifier for that asset. We need to set the admin for that asset, and we need to set minimum balance of the asset. And what minimum balance is? So minimum balance is a minimum amount of an asset that can be assigned to any account. Having created an asset, we need to kind of describe the asset. And the asset is described by its metadata. And what is it? What is it? What does metadata contain? So in metadata, we can find information about the name of the asset. We can find information about the symbol of the asset, and also about decimals. And what are decimals? So in that concrete example that you can see on my slide, we have decimals set to 12. What does it mean? So decimals is about asset precision. So one unit of that asset, I mean one LSPA, is represented with that decimals as 1 with 12 zeros. That's the precision. That is how we play with amounts without using fractals. Now let's talk about high-level features that are enabled by the assets palette. So as I mentioned previously, the asset palette enabled users to issue new assets, to mint new assets. Also, it enables to transfer those assets between many accounts, introduce some kind of complicated mechanism for transferring with allowance. I will talk about it later. Also, Pallet asset enables people to kind of destroy assets, get rid of them. It also introduces some kind of asset management, like setting metadata, setting roles, setting status for the asset. It will be covered later. And for sure, we have some functionalities for state querying. So with state querying, we can check, the balance of an account. I mean, how much of the asset that account own. We can check also total supply of an asset. So it's total amount of asset that has been minted on a chain and stuff like that. So Pallet asset contains 3 buckets of dispatchables functions that are called, that can be executed via submitting a transaction to a chain. So the first action is about creating a new asset. And for asset creation, we just send a transaction to create. We specify some asset details, and that's it. We have an asset created. And one point here about asset creation is that an account that wants to create an asset needs to have some money to pay a deposit for asset creation. Besides asset creation, just a regular account can transfer assets from itself to any other account. And also we have 3 last functions specified here. And what are the functions? So that functions introduce a mechanism that someone else can manage our assets on our behalf. So, for example, imagine a simple situation. I'm going to vacation. I'm going to lie on the beach. I'm not taking my laptop, any wallet with me, and I really trust Hector. So what I ask Hector is to pay for my bills. And what I need to do is to at first say that I trust Hector. I want Hector to manage my money. And this is the goal of approve transfer function. And once I enable Hector to manage my money, Hector can transfer my money with the transfer approved function. But what if I lost faith in Hector? I mean, I can cancel that situation. I can revoke that right from Hector of transferring my money with cancel approval function. Besides permissionless functions, we have some functions, some extrinsics to be executed with only specific role. Let's go through them. So at first, what I have on the slide is start destroy. It can be done only by the asset owner, and it's about starting the process of destroying an asset. Besides that, we have a functionality to mint new assets, new tokens, and it can be done only by the asset issuer. We can burn some minted tokens, and it can be done only by the asset admin. We can do some forced transfers. And what is forced transfers? It is a transfer done without asking for a permission. So anyone with the admin right can transfer my money without asking me about permission for doing that. As I mentioned previously about freezer, so freezer can freeze asset on specified account, also the whole asset class. We have the opposite action to the freezing mechanism called DOL. We can also change the ownership of the asset with transfer ownership, and only current asset owner can transfer ownership to someone else. I mean, the reason for doing that can be anything. For example, asset owner doesn't have time to think about that asset, doesn't have time to play, to take care about it. So it can transfer it to anyone else. Besides transferring ownership, asset owner can play with asset metadata, like set the metadata for the asset, can also clear metadata for the asset, and also manage asset roles. I mean, the roles that I described previously with set team. So set team is an extrinsic for setting the roles like owner, issuer, freezer, admin, stuff like that. Besides privilege calls, we have also permissioned dispatchables. So those are only force extrinsic from the asset palette, and that extrinsic can be only executed by accounts that meet the requirements described in force origin trade implementation. About force origin trade, we will discuss later. So just remember that for those extrinsic, our account needs to make the requirement described in that implementation. So the first extrinsic for about force action is about force creation, force asset creation, and it's kind of the same as just regular asset creation, but in that specific example, an account doesn't need to pay any deposit for asset creation. No deposit is locked for asset creation. Besides that, that privilege, that account can manage metadata. I mean, setting or clearing metadata, also can set the status for the assets, and also cancel approval. So having described the possibilities with the Pallet asset, let's talk about the dependencies with other pallets, tools, stuff like that. So imagine a situation that someone needs to use Pallet asset in its own runtime. So that person, that developer, that team, that entity needs to implement the configuration for that pallet. And in that configuration, there are some attributes that are kind of solved with other pallets. And one of the attributes, one of the traits, one of the behavior that needs to be implemented for the asset pallet is a currency trait. And in most of the runtimes that I have ever seen with Substrate, it is met with pallet balances. Also, we have force origin trait. So this is the trait that describes the behavior who can trigger force actions. And in parachains like StateMint, it is done with pallet pseudo. We have also create origin trait, and the trait is about setting who can create a new asset. In regular asset, it's basically mainly just any account. But in bridge operation, we have different attitude. I mean, when we talk about bridges and assets and bridge assets, there is another way of handling and creating bridge assets, but about bridges we will talk in the future in our learning session. The last thing to cover by me is about usage of the pallet in the ecosystem. So when someone needs to just play with fungible assets, he or she can just use the asset in the runtime. It can be in solo chain, it can be in parachain, it can be parathread in the future. So that's for regular asset usage, but also both in Polkadot and Kusama, we have dedicated parachains for playing with assets, both fungible and non-fungible. Those parachains are called StateMint on Polkadot and StateMint on Kusama. And on that parachain, pallet asset is used for playing, managing regular fungible assets. And that's all for me. Abhishek, the floor is yours.
So this is statement, as Daniel was mentioning. There's a state mine and statement, which are asset parachains. So these have uh, the runtime module pallet assets, and here you can see the assets that exist on statement. So you can any dot holder can create their own asset by reserving some of their dots and taking a asset ID, which is a U32, and they can give their asset a name. And as Daniel mentioned, they have different. You can assign different roles to either yourself or to someone else. So you have roles like freezer, owner, or admin. So let's now jump to our local chain where we can see some of these pallet asset actions live. So I'll just switch. Great. So I'm running the substrate no template, and here you can see that I have two assets called Cake and Cookie, and Alice and Bob respectively own them. They have a supply of 50 here, and this was created in the Genesis. So I actually wrote this asset configuration in the chain spec file, which is which is what you do if you want to start your chain with some Genesis state. And right here, you can create under network tab assets, you can create a new asset for yourself. So we'll first go over asset creation, then we'll try to mint some tokens, then we'll transfer them, and finally we'll destroy them. So you can think of this demo like a full asset life cycle. So we'll keep things simple. We'll say Alice, and asset name maybe LSPA, or deep dive, and let's give it a symbol ice, decimal 3, and minimum balance, let's say 9, and asset ID is 3. So Here you'll see that there are two actions needed. One to actually define the characteristics of your asset, and the other would be to specify the role. So issuer, freezer. So this can be someone else, but for the purposes of this demo, we'll keep it simple. So everyone is Alice. Alice has privileged. Alice has privileges to those calls that Daniel was showing. Alice can issue tokens, and Alice can also freeze. Freezing means stopping all transference on chain. So we'll go ahead and create it. Sign both transactions here. So twice. And on the top right, you can see it was created and some balance was reserved. So depending on your runtime configuration, some amount will be reserved so that not everybody can take up on-chain storage basically. So deep dive has been created. Asset ID is 3, and let's go ahead and mint some tokens to. Let's do it to Alice first. So remember, it's the minimum balance I've defined as 9, so I can't go ahead and just write it. Polkadot.js is smart and it won't let me do that. So let's go ahead and make 1,000 of these. Sign it. And there we go. We have 1,000 ICE tokens. And the next thing that I want to cover is how do we transfer it. So it's an asset, you need to transfer it somehow. So yeah, this is another tab right here. So under balances, if I hadn't minted deep dive tokens yet, you wouldn't see deep dive right here. So just because I minted it now, you can see that it shows Alice has 1,000. So we can come over to this tab and send some money to Bob, let's say, or why not Charlie? Let's send it to Charlie. So maybe 20. And there we go. Charlie has now 20 ICE tokens. Something to note here. You'll see that sufficient is marked as consumer here. So there is this concept of asset sufficiency, which basically says that if the asset is sufficient and if some account holds a sufficient in quotes, holds a sufficient asset, they don't need to hold the existential deposit of tokens that ties in with the balances account. So if you'll remember, um, in general, in Substrate and Polkadot, you need to have a certain minimum balance to actually have on-chain storage. And if your balance drops below that, your account is reaped. But assets and the same idea flows over to this. So in StateMind, StateMind allows you to have sufficient assets such that if an account holds some asset that's marked as sufficient, you'll have a record on the chain. So that's something I want to cover. And just because I started Cake and Cookie as from the Genesis, they're automatically marked as sufficient assets. So if I switch over to Cake, you'll see that it's marked as a sufficient asset. Another way to check all this information out is in chain state. So I'll just go over to assets, and I can type in the asset ID that I want to check, or I can just remove the option, and you'll see that it shows me all assets that are in storage currently. And only for our asset 3, which we just created, is sufficient is false. For the rest of them, it's true. So is sufficient true right here. So yeah, that's something to keep in mind. And let's go over and uh, freeze some assets. So I'll come over to Extrinsics. So remember, Alice has all control. So she's admin of ICE tokens. So let's try and freeze some tokens. So here you'll see there are two freeze calls. One is freeze for a particular person, and one is freeze the entire asset. So freeze asset for ID takes some ID and freezes all transfers. And this is one of the steps, one of the preliminary steps that you need to take if you're trying to destroy the asset. So, like I mentioned in the beginning, we are trying to go over this entire asset lifecycle from creation to minting to transference to finally destroying it. So, right here, we'll first go ahead, since we are inching towards destruction, we'll first freeze that asset. So, I'll just submit this transaction. And you can see it went through. And now if I try to do a balance transfer, it should fail. So let me send Charlie some amount. Yep. And it's token below minimum. Oh, I guess this is something else. So just to make sure, I'll make it 20 again. And oh, I have the wrong. It was deep dive. So that's my mistake. So I'll send 10 year, and it should fail. Yeah, asset not live. So this was what we were hoping for. The asset has been taken off. And the other call that Daniel also mentioned, thawing or unfreezing as it's called, will reverse this action that we just took. So back to extrinsics, assets, and here you'll find thaw. So thaw will reverse whatever we just did. And after thawing, the asset goes back to live. So yeah, finally, let's start destroying this asset. So we want to get rid of it. So there's a process for getting rid of it. First, we call the start destroy dispatchable. Then we remove all approvals and all accounts that hold that token. So approvals, like Daniel mentioned, delegated calls. So we want to remove all that, remove all account balances, and then finally we can conclude the process with finish destroy call. So I'll just walk you through all of that. So start destroy ID 3. Let's go ahead and submit that transaction. Since we didn't create any approvals, we don't need to go through that step. And I'll just jump over to remove account. So let's see, destroy accounts. I believe this was the call. So, and finally, we'll conclude it with finish destroy. So where was it? I just caught a glimpse of it here. So yeah, now we shouldn't see any trace of that asset, and yep, it's gone. So ICE token was removed completely. So this was the complete asset lifecycle. There are other calls like creating uh, approval. What was it called? Transfer approvals. So I'll just show you that real quick. So it's called approve transfer. I believe it was this one. Yeah. So we can't use asset ID 3 because remember it was destroyed. And we'll say, okay, Charlie has access to now. Yeah, something about this. The number I'm going to write here is big because there are 10 decimal places in the asset ID 1. So I'll say 20 followed by 10 zeros. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And submit that call right here. Yeah. Now, as Charlie, you should be able to use Alice's tokens that she just approved. So we'll go ahead and transfer approve. So asset ID 1, we'll send it. Let's send it to Ferdy. And oops, this was the owner. So Alice owns this. A destination Ferdy. and amount, let's say 15 followed by 10 zeros, 1 2 3 4 5 6 7 8 9. I hope this doesn't run into some minimum balance issues, so let's not fill it up. Let's keep it in fraction. It should go through that. Yeah, I knew it. There is let me quickly check what's the minimum balance over there. It's 10, I believe. uh, yeah, it's 10. So 15, 1 2 3 4 5 6 7 8 9 10. Yep. And just like that, Charlie was able to send tokens. Let's check. Ferdy has 15K. And so, Alice entrusted, um, who was that guy? Was it, I forget his name, but yeah, this was basically transfer approved in a nutshell. So, yeah, that does it for the demo. I believe it's Hector's turn. So, Hector, over to you.
All right. So now what we are going to do is do the code walkthrough, right, for the assets palette. And before I start, I want to basically share with you that instead of going like in very depth on how the palette works and how the extrinsics works, what I want to basically show you, right, is that I want to show you how like you as a builder, as a developer, you can like use all the interfaces or all the implementations that the assets palette provides, okay? And basically how you can rely on those interfaces for using the palette assets into your custom palette. So I want to first start by reminding where you can find the code for the palette assets, right? It's basically on the substrate repo under the frame, okay, where we have all the frame palettes, and then specifically the assets folder is where you can find all the code plus this documentation, right? So you can see like a couple of things like we mentioned already. You can basically get the description right here of each functionalities, configs, and so. So if we go, okay, to now the code of the assets palette, let's review the structure like very quick, okay? So let us start speaking about the configs trait. Okay, this like trait which basically defines which sites are you going to receive from the runtime. And yeah, you have like, for example, the asset ID parameter, right? This is important in my opinion, the currency, right? If you check what kind of type is expected here is a reservable currency, okay? And this is kind of important because, for example, oh, I think I deleted by mistake. But for example, if you look for this type, okay, in the create extrinsic, you can see like once the asset is created, you have your balance, right? In this case, from the native token reserve, and that's thanks to that type, okay? This is the config trait. And we have the currency type. And this currency type receives a reservable currency. And basically, if you go to the create extrinsic or the create call, you will see that in here, right, that type, the currency type, is being reserved. Okay, as I was mentioning, if you want to have like more details about how this mechanism works, you can basically go to the session, to the palette balance session that we did in the deep dive. Yeah, you can have like a full description of this. So yeah, if we go back to the config trait, okay, you, for example, have here the asset deposit, okay, which is the type like basically sets how much of amount, how was the amount that you need to basically use, or you need to like reserve in order to get your asset created. And then there is one, okay, that is very interesting and is quite new. It was like added like 5 months ago at this time of the recording, which is the callback handle. Okay, so this was interesting. I didn't know the existence of this one. So basically, once you create your asset, you can basically have a callback function called. All right, and I think that's very useful. You basically can like set it up and configure that callback from your runtime. So, for example, this is the runtime for StayMind, okay? And in this case, StayMind does not configure any callback handle, but yeah, you could basically do it from here. You could define your own callback and yeah, basically share it here, all right? This is like an example of how like you could configure in your runtime the assets palette. In here, you have like a couple of values that are defined, like for example, the asset deposit, the account deposit, the approval. There are like, yeah, a few values like you can basically set up here. For example, you have the create origin, which basically origins are like allowed, right, to create assets. Or for example, the force origin, that if you come here, you see like you can force, right, if you want to force the status, or you want to force, right, the creation of an asset, this is how you basically, this is an example, right, of how can you set that origin for forcing status or creations, okay? But when I started this like a walkthrough, basically I said that I wanted to show you how you can use all what the Pallet asset provides to you, okay? So you can use it in your own Pallet, and this is what we are going to do. So if we take like the structure, okay, for the folder structure for assets, the assets palette, you can see that in the source, there is not only like the code of the palette, but you have like a few, you know, files which are interesting. And if we want to talk about the assets palette, okay, we cannot like describe how it works without talking about the fungible trait. Okay, this fungible trait is not like, how to say, like it's not part of the assets palette, okay, but it's very much related to it. It's very much, it's like a strictly related, if we want to say. You could have your own implementation of a palette that handles tokens or assets, and you could basically rely on the fungible trait for define your share behavior, right? Or your interfaces, if you want to call it like that. So we have a few here. So for example, inspect, right? This could be like an interface to basically query or to inspect which assets are created, right? You could like, for example, implement a function that retrieves the total issuance for that asset by providing the asset ID. You could get the balance, or then you can use this can deposit and can withdraw, which is more advanced, all right? Then you have inspect metadata. Okay, this is basically used to, as Abhishek basically he shown in the previous part of this learning session, like you can like basically inspect like the name of the asset or the symbol or the decimal. You remember that when you create, you have two different like for create an asset, right? You have two stages. First, you create the asset, and once the asset is created, then you assign the metadata, right, to it. That's how basically, when you create an asset from the asset stuff in Polkadot.js, it's basically executing these two, right? First, creates the asset and then sets the metadata. And then you have, like, for example, the mutate trait. where you can, like, for example, mutate the state of an asset. And here you have the mint into and the burn from. This is, you can understand, like, or you can like imagine what this is doing, right? What kind of mutation is doing to the asset. It's basically allowing you to mint or change the supply or your asset, okay? But this is just the fungibles trade. At this point, without this, right, just having this, the assets palette is not able to do anything with it, right? So that is why, if we go into the into the folders of the Pallet assets, you will see like we have the impl fungibles. All right. So if we go to the impl fungibles, what it's basically doing is saying, okay, for my pallet, for this pallet, which is the pallet assets, I will implement the fungibles trade. So I will say that this pallet requires, right, the fungibles trade. And yeah, for example, let's go into, well, we can say here that we have the spec, which is the one that we called before, we mentioned before. We have the spec metadata, okay? And what we are doing here is basically saying, okay, we are going to implement that trade that we saw before that has like a specific behavior, right? Then what we are going to do here is to say, okay, which functions or which implementation we are going to use for this one in particular. So if I want to implement my fungibles mutate trade in the pallet assets, what I will basically do is call this self do min function. And okay, we say where these functions are defined. So what is this doing? Okay, so the pallet assets has this functions file where you, for example, you can look for do mint, and in here you have the code specifically, right, that is being performed on do mint. So basically, this impl fungibles has this mint into, okay, and with the functions, right, is exactly what the code is doing. All right. So if we go here, let's go to, for example, in the palette, right? In this case, we don't have like a specifically how to say, like a mint into, but you will see then where is this used. Okay. So all right, doing like a little recap. So we have the impl fungible. So we have the fungibles trade, which defines a shared, behavior. Then we have the impl fungibles, where it says for this palette, we are going to implement those like interfaces from the fungibles trade, which is the mutate, right? Which is the inspect. And also we have the transfer, okay? And once we define this with basically this pattern with the do, right, underscore action on the functions, right, file, we said which code are we going to execute. And okay, basically what I said is like, I will show you how basically you can use this all these interfaces that the assets palette provide into your own palette. And this is why what I will do right now is to show you the code for a substrate DEX. So this is like a non-production palette, which basically creates or implements a decentralized exchange. This is non-production. This has no profitable purpose. It was just to basically, it was an internal practice that we basically did in the team just to go in depth about like how to interact with all these like interfaces from the pallet assets, right? But by no means this basically shows any kind of a real economic, right, value held in this palette. Also, you should not like implement this text in your production runtimes, but you can basically use it if you want to, I don't know, start a testnet and trying basically playing with the palette assets types. Okay, so let's basically take a look at this palette, this DEX palette. So what we have here is in the config trait, we have, for example, right, I want to show you that we define a type assets, and we basically show, we basically require this type to fulfill the inspect, then the and the transfer, okay, types. This basically, if we go to this, right, it's basically require that that type implements, you know, the mutate and the transfer traits. And also, like on the asset registry, we see like also is required the inspect, is required in this time the mutate trait, the create and the destroy. Okay, and all this comes again from, yeah, the fungibles trait, which is basically provided by the frame support. All right. So, all right, you have these types, the assets and the assets registry, and this is the concept that is called loosely coupling, right? When you want to loosely couple your pallets, right? In this case, we are loosely coupling this DEX palette with the assets palette, all right? So this is the way to do it. Basically, you define your shared behaviors in traits and you implement them, and then by exposing all those like shared behaviors or traits, you could then loosely coupling, right, into your own palette. So this is interesting because let's take a look, for example, at the add liquidity function, right, from this palette. What is this doing after, yeah, all the basically the logic from the DEX, which I basically will not go into, is like basically is calling the assets, okay, is calling the assets transfer method. And also the assets registry is calling the mint into, all right? So if I want to take an example, right, of how this palette can be implemented in runtime, here I have an example, okay, from the Trappist parachain. Again, this is also a non-production parachain. It's a showcase. It's a parachain basically used for showcasing new features and stuff. But what I wanted to show in this case specifically is like when we implement the Pallet DEX in our runtime, I'm basically setting, or I'm basically providing into the assets and assets registry type, I provide the whole asset instance. All right. So this assets instance, if I go to the construct runtime, is basically the Pallet assets. All right. So when I'm doing an asset registry mint into in my palette, what is basically being executed is in the functions, this code. So this is what is going to happen with the asset. And it's basically happening thanks to this all group of fungible traits, the impulse, right, the implementations for the fungible trait on the palette, on the assets palette, and finally these functions, which is the code that is manipulating the storage for the assets and stuff. Which also I think kind of makes sense to go through the storage as well. Not specifically right on all the storage items on this one, but yeah, you have the asset, right, which is basically a storage map that with the asset ID basically stores the asset details. You have the approvals, and also you have the metadata, right? So basically this functions file is manipulating all these in a way at the end is manipulating all these storage items, okay? Something interesting about the assets palette is that, for example, Abhishek when he was talking about the sufficiency for the asset, he basically mentioned like what he put like in a Genesis config. Okay, he put like in the chain spec. Sorry, he said he created like some assets already. So when the network was spin out, there were some existing assets as part of the chain spec. And something which is super interesting about this, and you can take for your own pallets as well, you can take inspirations, is how you could basically set, right, in your chain spec initial values for pallets. And in case like you wanted to start a network with the assets palette, but you want to have like basically some assets already instantiated and created, right, in your first block or your Genesis, right, block for your chain, is basically by this. You should like in the chain spec, you should provide these 3 vectors, right, where you basically set the assets, right, what you wanted to create. You provide here different information. Then like you have the, well, here it says, if you wanted to be specific, the ID, the owner, sufficient, and the minimum balance. In the vector for the metadata is the ID, again, the name, the symbol, and decimals. And lastly, the accounts, okay, which accounts are basically receiving, or you are like basically if you want to give like an initial balance for the asset in your inner chain spec. So here you have all the description about how, or all the code about that initialization is basically executed in your chain spec. All right. Lastly, something I wanted to show you, which I think is very cool, is like in the types file from this palette, you have this balance to asset balance converter. This is an struct that basically works as a converter. And basically this one is getting a balance from, if I'm not mistaken, I think it's the currency trade, and it's basically converting it into an asset balance. Or yeah, let's making it simple. Yeah, this is like, yeah, it's a balance of and an asset balance of, yeah. So basically this is getting like, you provide a balance, let's say from the pallet balance, and it basically, it converts it to an asset, you know, balance. And how basically, which was the way, or what is like the mechanism like this converter uses to convert one type into another is by comparing the minimum balance, right? The minimum balance setup for both. So the existential deposit in other terms, okay? It's like documented here. And if you wanted to see how this is implemented, you could go to StayMind and you could see like this is basically used for the Pallet Assets TX payment, which is a pallet that is basically, their purpose of this pallet is like you are allowed to pay fees in the network with a sufficient asset, okay? How it basically makes the conversion about how much assets you need to pay instead of, you know, the native token amount is, yeah, determined by this converter. So yeah, this is like the review. We are like, yeah, reaching the time for this learning session, but this was like the very quick code review about how the assets palette is built, and also how can you use it through like these fungible traits or these shared behaviors into your own palette.
Thank you guys for making that session. Again, thanks to everyone who listened to us, who participated. I hope you enjoyed our session and see you next week.